Welcome to the Databricks Skill Builder series. We're glad you're here.
Yeah, so Vinita might be running a bit late, but I can get started. So today we'll be focusing on Databricks Feature Store. And like down the entire session, feel free to drop your questions and we can get Vinita answer it, or like she can raise the question to me and we can answer it while we go through the presentation and the demo. Right. First of all, before we dive into like the feature store itself, let's first understand what exactly is a feature, right? So let's use, again, a very basic example of a like recommendation engine. So we'll look into like first the raw data, and it includes the user table that has the attributes of like the registered users. It has the item table, which stores information about the item you are like trying to sell. It'll have another table called the purchase. It'll record all the items that the user have bought before, right? So these were the raw data. Now we want to build a machine learning model to predict, say, the likelihood of the customer buying a specific item. So essentially, you are inputting like everything you have into your machine learning model, and those inputs are called like features, right? And the output you get is a prediction. Uh, Yeah, so like let's dig into like what kind of features there are, which might be meaningful for your ML model to generate predictions, right? One basic type is the transformation. So for example, you have a product with say a couple of categories. You want to encode that category, say, into like an integer, right? Since your model only understand, excuse me, numbers, right? It doesn't understand A or B. It understands like 1, 2, 3, 4. So you want to like kind of like make those transformations so that the model can understand it better. Then you have second kind is like the context features. So these are features that change within the context of your like the prediction. So for example, location or device you're using when you are making those purchase, those would be a kind of like the context feature. Then you have augmented feature, right? So these are uh, like sometimes you want to improve or augment your data using some third-party data. And one particular example could be, say, some weather data, right? You want to use that data to join to your raw data set to help predict the purchasing behavior, say because of the weather, it's cold and now you want to grab some coffee and like get some tea, right? So those are augmented features. Now the last is like pre-computed features. Uh, so this could be like some windowed aggregate. So these are usually expensive to be computed every time. For example, the number of purchases a user has made in a certain time period, right? You don't want to compute these like in every model. You want to kind of compute it once and store it so that you can like keep using it next time you are running a model. Now, so you know how to determine like which of these features should be feeding into your like feature store and which one should not, right? And it'll vary with industry, case to case, use cases, all of it. Uh, yeah, so let's move on to the next slide. So in this, so okay, so this has to do, let me go back once. Okay, finally, a very common feature that are useful in recommendation system are this time window aggregate, right? Uh, so as you kind of go through it, I'll talk more about it a bit. So let's wait for that. Okay, so there are other features called like pre-computed features. this is sometime, it's like, as I said, it's very expensive to compute. So it can also be something called like customer lifetime value. So these things you have to kind of make sure it already exists for that customer. The number of purchases we talked about. There's another thing called like runtime features. These are features that are like generated while training. So it's not known beforehand, but you will know it when you are serving a model or it's already live in production. You want to like make those runtime features running. And an example of that would be like your IP address or the like device, as I said. So these are very important as well. So we'll talk about those. That one I missed in the previous slide. And these feature usually needs to be transformed at runtime itself. So you won't be doing any of the manipulation beforehand. Right. So with that, let's talk about the motivation behind like Databricks Feature Store and what challenges we are trying to solve with this feature store. To begin with, let's look at the typical machine learning life cycle. First of all, you have your data scientist. He will grab all different raw data and iteratively perform featureization, oftentimes to kind of like speed up the entire write operation and just transform their data into some feature, like writes feature for their model. As a result, like features are not easily discoverable or reusable. They do it like with each use case, it tries to kind of accumulate over time. And when you move into like developing a new model, this whole process is like repeated again into maybe 6 months down the line, you totally forgot what you did 6 months back and you're recreating the same features every time. And after, say, the model is being like tested, it's ready, the resulting code itself are given to a data engineer or a ML engineer to kind of implement a scalable pipeline and make sure to kind of like serve them to a downstream application, right, for like various consumption. So usually data engineer won't have too much context about the model and the requirement for those model, which data scientists might have defined, right? So as the model like gets created, move to the next phase, and kind of repeated the same process again and again, you keep on like accumulating these all complex things, and it's not a great like handoff as well with different team members. So as a result, different teams, data engineer, data scientist, machine learning engineer, need to spend a significant amount of time just transforming those data, taking directly from raw data, so that they can make it usable and it could be consumed by your, say, machine learning models. So just to be more specific, the number one challenge is the lack of features stored, is like no reuse of feature. I think I will be talking about this like again. So basically you are like implementing a couple of times these different block of like not searchable from a centralized location like feature store, and like you are not really managing in a way that's reusable. And a couple of reasons is, first of all, usually the searches, uh, even you have a pretty like based naive approach to kind of search based on the name of the table, maybe, or some other like names you could think of. But that will require data scientists to kind of know and guess what is or should be the name of those like features. There are some like table searches which goes across industries, which doesn't use feature store. Those are like not scalable. And another reason is there's no way for a data scientist to know which feature are used in which model, right? So essentially, there's not really a lineage information with upstream or downstream. So you don't know this model used these all feature, so you can trust more on these features. So it make it like a lot harder to kind of reuse those tables, or even like if you want to delete a table or a feature, it's not a easy way to kind of like list out all the like outdated or tables or features which are not making sense anymore, right? So those lineage information is missing, right? So that's why there's no use of like previous features. And the second problem we are trying to fix uh, is this, like you have duplicated of effort, which creates more like compute, right? So let's say you have same purchasing history for your two like customer, right? You are creating a feature store which like spent for last 30 days, so calculating all of that. You actually need to devote two different models. One is I think the propensity model, and the other is the churn model. Both are usually using the same identical feature that are derived from the same data set, right? Over here. And in this case, the same feature will need to be computed twice, even though it's the same exact logic, same raw data that gets fed into it, you still need to recompute it. So there's really no sharing or reuse of the same feature. This really results in duplicated effort on your data science or your feature engineering team. And also you're spending more in compute to kind of like get two results. Right. And the second, like another challenge which we solve is this concept called like online and offline skews, right? So you can think of this as like subtle difference in your feature that are used to train your model versus what are like used for serving your model in production or online, right? So in a lot of machine learning use cases, models will need to be deployed in an online fashion, meaning you need to serve your model in real time at very low latency. So in this example, in recommendation use cases where you need to give recommendation to a user based on their, say, searches or their browsing history, and we will like need to return that result in millisecond context, right? So every time after a web page like reloads, you might need to push a new set of recommendation to the same customer, so that has to happen in really fast like fashion. And the transformation that we'll be using to compute those features at training time, or like in other words, like in offline fashion, now need to be kind of recomputed in an online context, right? And in real time model serving context, which is like at very low latency. So, and this often will lead to the team to implement these features multiple times and will introduce like some small differences in your feature between like the offline version and the online context, which might have significant impact in your like model performance, right? Like, in data science world, we're struggling for even like 1% accuracy. That's a big deal for us. And then like there's another challenge with this online offline skew that is caused by the difficulty of tracking the features that were used to train your initial model. So essentially, like there's no like lineage available. So there's no versioning of the underlying data or the model, or like the experiments kind of to understand the end-to-end lineage of your like the most accurate model, right? So we try to solve these challenges. And just to illustrate like in a more detail, here's an example. So say we have the same feature spend 30 days that we need to compute based on same raw data set. In an offline version, we calculated the last 30 days without, say, the tax like addition to it, right? In contrast, in the online fashion, you are actually calculating the same feature with tax, right? So there's some differences in the computation logic for these two features, and we can quickly change the pipeline that feeds the model without retraining the model, just to make things right. Right. So this happens like without feature store, but this will lead to slight differences in the data that feeds into your model. versus data that were used to train the offline model, right? So this is the main like scenario when you would try to go for like online feature store and get that like online offline skew removed. Yeah, I'll take a pause. I'm not sure if Vinita joined the call or not. Are there any good questions, Vinita? Me too.
Hey, Dipendu, I'm on. There was one question which is answered, but I'll let everyone speak up if they have any other questions.
Yeah. Okay. If not, like we can dig into Databricks feature store. Right. Okay, I'll pause for like again 3 seconds, see if someone has a question. Tick 1, 2, 3. Okay. So here's the whole Databricks machine learning data science ecosystem, right? You must have seen the slide a dozen of times. So Databricks Feature Store basically tries to connect all your data to your model deployment, right? You have data prep, versioning, and everything is powered by Data Lake, right? So everything is built on top of the lakehouse. Then you train your model, do hyperparameter tuning using Databricks, develop machine learning runtimes, and then you have like the built-in feature store that natively like integrates with the entire lakehouse, and it also supports like the batch and real time, both of it. So for based on the use case, you can pick and choose, and it's the easier version and no third party route for creating your feature store. Okay, so how exactly does Databricks Feature Store solve the two challenges we talked about? So the first one we talked about was there is no reuse of feature, right? So with Databricks Feature Store, you can actually discover and search features in the Databricks Store UI and reuse the same feature that were used by other known like good models, which you are sure that these are the best one, and whatever data feeds to those models are should be the one you should be using, right? We'll look into it like while I'll demo it like towards the end, but that is like the one critical thing. And then there is also this built-in automated lineage tracking. So basically, Databricks Feature Store can automatically track the data sources used for creating or for like the feature store computation, uh, as well as the exact version of code that was used, like the notebooks that were tied to those features. So this facilitates like the lineage-based search, right? So a data scientist can take their raw data, find all the features that are already being computed based on the same data. This way, they spend less time going through their own manual like feature engineering, and also save them from like introducing several differences that we're calling like online offline skews into the way the feature was created, right? In addition, there is this like integration between ML flow, the model format with the feature store. So this also gives you some like downstream lineage from features to your model, right? So the feature store will actually like know exactly which model and like which endpoints or jobs are consuming the specific feature, and give you end-to-end visibility into your downstream lineage information, right? That also helps you to make decision on whether you should delete or update a table in a safe way with minimum downstream impact, right? That's again critical. You don't want to like mess up your downstream system since you change a column which should not be changed because it's used for downstream, right? The second, like the point we talked about, the online offline skew challenge. We are trying to eliminate that using the native like model packaging. So the integration between MLflow and Feature Store enables feature stores to package up feature lookup, right? Those logics into your model itself. So when a MLflow model that was trained on data offline from a feature store, like it's deployed, the model itself can look up the features from the appropriate online store after you publish your online feature table into your like online feature store, and don't have to like build a separate pipeline for just like model inferencing, right? You can reuse those. And there is a really like no risk to introducing this offline online like skews, because any changes to your underlying features for used while like for training, that is automatically captured and can be looked up by the model like itself. So the online model will know what kind of like transformation went through. So your requester or your downstream like the team uh, don't have to worry about that. It's less complicated, and these feature updates can be made without any changes to your client code or like anything that calls that model, right? So just a little more details. So it was co-designed by Delta Lake and MLflow, right, to accelerate your ML development deployment process. Feature Store is basically a centralized repository for all your features in your organization. So you can save all your features in a central location across organization. You can do like search for your records, all the features which have been pre-computed features. You can know their definition, right? You know the computation logic that went in to create that feature. You know the data sources as well as the producer like notebooks or code that was used to compute those features, and the downstream consumer of those features. Like say if one feature is used by two different models, you know both the models which are using that specific feature. Say a column of that feature, you know that column is used by two different models, right? You know all that visibility before you kind of like make sure the new model you're developing. Yeah, and then we'll talk about the Feature Store UI as well. So you will be able to navigate throughout and search for feature store tables. For example, you know the feature store name, you can search by the name itself, or if you know the data stores that's used for the computation of that feature, if you search by the name of that data source, you should be able to kind of filter the related feature store which might be using the same data sources, right? And then you can look up and see whether there's some feature that are already used by other machine learning models, right? We talked about that. And then the lineage information, again, I mentioned that is captured as well. So you can identify data sources, the consumer that are linked to feature store. Yeah, and finally, let's talk about the batch and online access for these features. So you can navigate through the features tables to the features that are contained in them. So you can look into this table. These are the various features in that table, and you can see like which online stores these features are published to. You can have all the information in the UI itself. And lastly, you can control access to the feature tables metadata, right? You have all that like access as well. Yeah, so any questions and comments so far? Yeah, I'll take a pause, drink some water, but yeah, any questions so far? Yeah, we'll jump into demo next. Hopefully, like we can showcase the code to you, and then you can use it in your own environment. But it should be pretty interesting to see how it's working. Yep. Any question? If no, we can go ahead. Perfect. Okay, so this notebook, we're looking to like again a very old but famous like New York taxi fare data. I think many of our accelerators also use like similar New York taxi data. So I'm using like those data to try to predict the fare of a specific trip, and I'll walk you through that example end to end and show you how like feature store is leveraged. Right. Okay. So here is my raw data. Right. This is the taxi fare data, which has the pickup, drop off, date, time, zip code. In other words, like the location information. It also has the trip distance, as well as like how much the trip cost. Right. And then the features I'll be computing. Today we'll have two different set. One is the pickup, and the other one is the drop off. And these will be derived from your raw data and saved into your offline feature store. And then we will use those features to train a model offline, right? And then make inferences in a batch mode as well. And at the end of demo, I'll show you how to publish these offline feature into an online feature store. If you need to do a real-time serving in online fashion, so you can like leverage that code to build your own online version as well. Right. Yeah, you can skip a command to just I'm creating a new schema so that I can store everything in my schema. But let's dig into command 5 over here. So the first step of featureization is to compute these features with your transformation logic. You derive like that information from your metadata. Right, so we will do that. Here you are just like reading the raw data from your storage location into a Spark data frame. In this case, it's a delta table, and you can see this how this raw data like looks like. Yeah, you have the date time of pickup and drop off, distance, fare, zip code, and the drop off zip code, right? So that's the data, and this is how it'll look. So as I mentioned before, we will compute two set of feature. The pickup feature, which will include the number of trips within 1 hour time like window, and the mean fare within that 1 hour time window, right? And we will be using, you can again skip this helper function. It's just like so that I can like reuse it. But basically in this, you pass it to a data scientist. You come up with your like say own logic that makes sense in your business context to compute these like two feature. Right. So these are the featureization logic which is used to derive those features. Right. In this case, I have two different set of like function, two different features. And yeah, I'm not going to go in detail like why we're doing like each of the grouping and analyzing, but it's just like cleaning up data so that you can create like two different features, and you can have your own logic based on whatever use case you're trying to kind of go with that. So, and these two function will be used here, where we are applying those logics into your raw data, right? And coming up with two new features, one for pickup, one for drop off. Just by applying the feature function in my raw data, and I'm just computing like the specific time frame, right? And this is how the data would look, right? So you will have two cleaned like zip column, and then the TS, the timestamp. It also added another like columns that's like year, month, and two main like derived feature, right? So the basically like you have the mean fare and the count of trips, like all of that, we'll calculate it over here. Yeah, command 16 is just like the underlying data of the feature tables are all delta tables, right? So you will have all versioning benefit of your data as well as the other performance benefit automatically inbuilt with your feature store tables, right? So we are creating this database so that we can store data in. Yeah, this is the first step of like calling the feature store client, and you just need to like instantiate it so that we can keep using FS down below. But so you instantiate feature store client, and then you have the first and the most important command in this entire notebook is this create table. So we are ready to kind of actually create those tables in your feature store now. You will use this create table function, and within that create table function, there are a couple of parameters you will need to specify. Name, and make sure the name is like the database dot table, right? And then the primary key, you can put it again. It's a mandatory field, which is not mandatory in data tables, but you have to make sure the primary key is associated so that you can look up a specific like feature based on the primary key, right? These are again very important. So this also like shows the model that like what features to look up when it comes to solving. So there's a like primary the join keys, right, that are used to look up that feature. Those are specifically the primary keys, right? So make sure you specify a unique key, right? It has to be unique for each record. Then DF again. So data frame is, you can either do it this way, you mention the data frame itself, or you can just put the schema and then add data afterwards. But in this case, we are just directly mentioning data frame. It can create that feature store table using this data frame. Partition column, again, is an optional field. So in this case, I'm just using year month column as a partition column, which might be maybe a very common case which you have been using, because the data is not that granular enough for a daily basis, but you want to store at least at a monthly basis. And again, description is just an optional field. You can put anything you want. It gets stored in the feature store description object, right? So this is again repeated for the next table in the drop-off feature table. Now you have two different features created, right? Yeah, I run that command yesterday evening, so we should have the feature store created. I'll walk you through the UI a bit. Okay. So, okay, I didn't talk about the UI. So you might be seeing this newer version of the UI. So you see this disable new UI feature. Databricks is like evolving at a very fast pace, and we recently made this UI update so that you can see all the things available to you in just one like site, and then you can like reduce the number of click to go to other pages. Yeah, hopefully you have been liking the new UI. I personally am, because I don't have to click multiple like personas to go into my dashboards or do something else. So in this new UI, click on the like machine learning persona, click on feature store, and then hopefully it works. Yeah. Yeah, and then you could see all different feature store tables, right? Here's the search box. You have like the feature table, feature data sources. You can filter by any of that, right? This is new, so you can also filter on like which catalog you're searching. So with Unity catalog, this got enabled. So in this case, say I want to search for a like specific feature name, right? But you can do it in any way you want. So this is my feature store database, and it'll have two different version of feature, like drop off and pickup, right? So yeah, so in this feature, you could see the like last modified, written by all the metadata, the partition key we have been using, the data source itself, right? So these are basically delta table where it's being stored. So you can like get the version history from this particular location. Description, the text we just like dumped over there. You can mention various tags so that you can like quickly like search or even like track your consumption like trends. Right, producer is the notebook. So this is the notebook we used. Yeah, online store is not enabled for this one, but here's the feature. Right, two separate features. You can see which all models these are using. So in the notebook below, we will be running some models, and that's being used, that's using this feature. So you can see all those models in here. Right, so this is the UI. Yeah, it's pretty neat, and you can track all of the lineage as well from here, and all the notebooks. This is being generated. Right. So yeah, so here's the update feature. So going back to the notebook and like looking in this step, you created the feature store table, and now you want to kind of like update like a specific feature. Oftentimes you will need to kind of do a regular basis update. Suppose you have a customer lifetime value that's get updated say every month, right? So you want to make those updates. So whenever you have a new batch of data coming in, you want to just compute those new data and save those into feature, right? In other case, it will be some static features, say credit score, right? So probably every week or month for a customer lifetime value, you want to compute those, right? So that's when this update feature function in the write table command will come in. So this is the raw data. And hopefully you're aware of display command. This is again a Databricks made a very neat command. You can do multiple visualization along with like display. So definitely use those and then click on this plus and get some visualization in the notebook itself. No need for a dashboard. Yeah. So coming back, so in this, you have this write table function to update those features. There are different modes to it. So you have something called a merge mode, and then you have overwrite mode. So merge will kind of like make sure it's added to the existing table. Overwrite will be like replacing the entire table, right? So we will be using this, and then if you want to do some sort of like streaming use case, you could also like have similar code built in, and you instead of here you can mention that the write table would be like streaming example, streaming feature. It's a streaming data frame. Checkpoint location you have to mention, and the processing time is like every 10 seconds. So again, a pretty neat way to kind of like do all your streaming use cases as well. Right. So in this next block of code, we are just doing like taking those feature store table, and like first of all, we want to make sure that everyone has like right access. So once you have like the right access to kind of make sure you can update those feature table, right? This is just and view the data, and this is just a SQL query to kind of like capture those, like some of all the count, top of is weekend from this, right? You can do like multiple SQL queries or any of the modification if you have right access. And this percentage SQL, it's a way to kind of run SQL command even when the notebook is a Python notebook. It's again a very neat way. You can even work with Scala if you want to, or in the same notebook. Right. So in this one, like I showed before, you will need to be able to like search and discover features. You can do that through the feature store UI. and be able to look up set of those features in a like centralized repository, all of that, right? Next, let's train a model, right? So here I'm cleaning the raw data first, and then I need to create a training data set that is just okay. Here's the workflow how I'll be doing the training data frame creation, right? So you will have the raw data. In this case, it's just the two feature store table we created, and then so that will basically create some sort of like training data. We'll merge it with some additional data, and we'll merge using the primary keys of these tables, right? So basically, your data needs to contain the primary key or the lookup key that can help you to look up those features from those feature store table. So an example would be like if you think of a customer perspective, you typically just use customer ID as a lookup key, right? To look up like for this customer, what are the other features I should be looking up to? And you want to build a, say, a churn model in one use case using one feature, say customer lifetime value. And in another case, it could be like some other different use case. This again with the same customer feature, right? So you don't have to like do like for same customer ID, with some of your raw data, you're merging with some other feature store, which might be totally a different set of like saved data, which you can reuse again and again, right? Without having to recompute those in different models. Okay, coming back to this case. So we are just using the zip and the date time as the primary key to look up those features and create that like training data data frame with those features. So it will have the existing feature store plus the additional features all in one, right? And then you have the feature store lookup library, right? So with this command, you can like check and like get other information. So you need to specify the feature table. You need to kind of look up from and which feature you want to gather from the feature table. So you are mentioning all the feature names, which all things you want. And you have to showcase like the lookup key. In this case, these two are the lookup key to make sure it's unique. Right? So after you define these feature lookup logic, you can start to create your training data set, right? As I mentioned before, this feature store integrates tightly with MLflow. So you can start MLflow experiment over here and yeah, start run over here, and then and you can have all that like stored and compare those runs side by side just to see which is the best model, and all the artifacts, including the parameter, metrics, the model themselves, and all the metadata requirement for are like all packaged together so that you can like see that in a clear way. So the model can be taken easily and deployed into a model hosted application very easily. Right. So in this case, let's look into this thread. So within the MLflow run, I'm creating a training data set using fs.create training set function within my feature store client API. I'm just passing my cleaned training taxi data. Here's the lookup with the like key to it, right? I need to specify what labels, what's the target variable called in the training data set, right? And exclude columns which are like not needed for my training. And that creates this run an experiment. I can show you quickly. right? So you have all that packaged together. There's one thing I want to show you as well. So even if you run the same model like multiple times, MLflow tracks slow. 1 month ago, I did run it and it's stored over here, the different on the same model. I can add uh, any other metrics I want for this like model from here and compare directly on this page. But if you want to dive deep into one specific model, you can like click and see in all of the artifacts are packed together, the parameters in that model, number of leaves it has, right? So all of these are stored. Yeah, I have 12 minutes left. I think we should be good. But yeah, so these are the MLflow piece, and hopefully you are a bit aware of MLflow. If not, definitely I'll recommend you to kind of check out the MLflow page as well. It's pretty neat. Okay, so coming back, here is the snapshot of the training data frame. So basically it has all the features from the pickup and drop off feature table, as well as the zip and trip distance from like my raw data set as well. So it has all that information. So yeah, so this is that. And then, yeah, so let's start training the model. I'm using light GBM in this example, right? So we will be using that particular package. So basically fitting a regression model on the training data set to predict the cost of specific taxi trip, right? So in this case, we do train test split on my like data, and then I'm running on the auto logging function of like MLflow runs so that everything is logged automatically. You don't have to manually log all the parameters or metrics. Right, the param is like the parameters that like I triggered my light GBM model by crossing this set of like custom parameters as well as my training data set, right? Yeah, so and that we will log models with MLflow, fs.log model, the model, the artifact path. In this case, you want to best utilize the integration between MLflow and Feature Store. You want to use like the Feature Store.log model itself. So this function calls the Feature Store API instead of the normal way of using MLflow API, right? So this is a new like additional functionality you get the Feature Store, and it has its own log model function as well. Yeah, this way Feature Store lookup logic can be packaged within the MLflow experiment. So that when you are serving the model at inference time, the model knows where the lookup those features and use like those to kind of train your model from Feature Store. And then you don't have to pass any specific features to your serving like version of the model. It knows what was used before. And within that function, you can also register the model to model registry, right? So you can mention a name and automatically the first time you're trying to create that like registry, it creates a version 1. And second time I run it, it'll create a version 2. You don't have to worry about anything else. You just mention the same name. Automatically the version gets maintained every time. See, in the previous example, this is the second time I'm running the same model. So it's giving the version 2. 1 month back, it was version 1. Right. So with that, let me show you. Yeah, so everything is packaged here. We go to data, feature store. Yeah, so you have the YAML file. You have the raw model over here. It'll have all the like the artifact needed. The requirement will have all the things you are using for that model. Yeah. So yeah, everything gets stored over here, the light GBM model, the YAML file, and you can directly use this to going forward, right? Yeah, so we were doing the offline batch interface inference, right? So this is happening in an offline fashion. So in offline context, you usually just use your offline feature store to train your model and then make batch inferences compared to an online store where you will use that for real-time model serving, right? So let's assume that you have another batch of data coming in, and you want to apply our same training model like to that. And in this case, for simplicity, I'm using the same raw data that was used before, and I want to apply that same model too, right? So in this case, just to show you how the data looks like, if you notice, we don't have any features in my inference data, right? Why this makes sense is that you usually, when you are serving a model, you are exposing either the application or the API to your downstream consumers, and they have no context what the features are used to train that model, right? So they have no idea how to compute those features. The only thing they might know is just all the runtime information, right? For example, in customer purchase or in recommendation system, current use case, any of that like use case, they will have the say customer ID, right? And sometimes like they have information about the devices, location information that are available for that consumer at runtime. They will pass all the information and make a request to application at a backend, passing the customer ID, and want to kind of get all the recommended products, right? Which the downstream has no visibility, right? They just have the customer ID and some other like runtime things they're getting in that like transaction, and they call feature store, get all the other information. So in this context, feature store is very helpful for your model to look up and get those features and then pass to your model. And in this case, this is like my inference data, right? And what I need to do with that is just first retrieve my model from my model registry by using the model URL, and then use the score batch function to like from my feature store client, and then pass all the raw interface inference data, right, to score a batch function, right? And at the back end, here's the chart that will illustrate this better. The same process as we created the training data set, right? The inference, all of that goes here. Like new taxi data will be created same way by joining our primary key to look up the features. So now our inference data can be populated to be passed to the model and make predictions. And finally, after you call the score batch function, there will be a new column added to prediction, right? And that prediction column will have all the predicted and attached to the same inference data set, right? So to take a closer look at the actual prediction, we have the predicted fair amount over here. Yeah, so we have the predicted fair amount and the fair amount. You can see how close they are, how the prediction was made, and it can be used to kind of like make sure you can do like say model monitoring and comparing these models to make sure there's no drift and other metrics as well. Yeah, so that was the offline side. Just quickly wrapping on the online side. On the other hand, you want to kind of make sure you want to do a real-time inferencing and serve that model into a real-time fashion. Data Feature Store also supports like automatic feature lookup for a couple of like online stores. So in this case, like I have copied example from Amazon DynamoDB, how we would do that, right? just update like your API keys over here, and it should be set. And the reason why we want to use online database compared to an offline is that like there's like latency issues, and offline store features like often like not satisfy the latency requirement, which is needed for online like recommendations. And online store are like very fast to support lookup and for those features and in online tables. Right. So the final piece of code, feel free to like look into it and then maybe create a copy. So usually you want to like publish the most recent snapshot of online store, and like get that so that your streaming can be true, and then you can do it in an online fashion. Just a time check. We have just 2 minutes left. So with that, like I will end like the demo slide as well. Yeah, so I'll like pause over here and get some questions if there are some. Vinita, over to you. Anything you want to talk about? Any questions which came out?
No questions on the chat, Dipendu.
Okay. Perfect. I think with that, I'll end my presentation. Hope you found it valuable. And yeah, looking forward to kind of interacting more. Feel free to look us up, like myself, Dipendu Chanda, and Vinita. We are there to help from Databricks side and help you